In problem 15, we have a fault plane and we have some Slicken lines. And what we have done in the field, we measured the fault plane and the trend of the Slicken lines. Let's say we don't have any measurement from the field that represents the plunge of these Slicken lines, alright, or even the pitch, it's not measured in the field. Let's see how we can obtain them on the Stereonet. So we're gonna do details on the Stereonet, but let me give you a little bit of information here, what we're gonna do. First of all, you need to plot the fault. Let's say this is my fault. I have only the trend of the Slicken line. So let's say here this is the center of my Stereonet, and what I'm gonna do is from the north I can go 74 degrees clockwise, and I can draw a line, right, on the Stereonet. And here we have Slicken line and we have the plane, right? And the intersection of these two, okay, we can highlight this point, and you can actually, rather than drawing that, you can only just put a sign on 74 and just highlight this intersection, because this intersection is important for us, right? So I'll put the dash line here. So what I can do right now, I have the intersection of the linear feature and the planar feature as a point, and you can read the trend and plunge, right? The trend is 74, we have it, right? It's the same thing here. For the plunge, you can actually count the plunge of that point. So you can also measure the pitch, and if you remember, the pitch indeed is the angle of the linear feature and the strike of the fault plane, and that angle can be counted here, right? Let's call that one as a alpha. So we can measure plunge, and we can measure also the pitch of the Slicken line on the fault plane. Let's see how we can do on the Stereonet in details. In problem 15, we have a trend of the Slicken line, and the fault plane has a strike of 120. This is 90, 100, 110, 120. Okay, and it's dipping 50 degrees towards north. So this is the strike, is dipping that way, right? It's roughly is fine, right? But in particular it's dipping towards northeast, but towards north still should be fine. So what we need to do, we need to count from this end 50 degrees, right? So let's place that one. This is a small line along the north-south line, and count 50 degrees and draw the great circle. 10, 20, 30, 40, 50. This is the fault plane, right? You should be able to do this problem because we had some exercises. So now we have the trend of the lineation, which means in the field they didn't measure the plunge, right? They just measured the trend, and the trend is 74 degrees. So if I'm gonna draw the trend, this is right. Let's first we find 74. Here this is 80, right? You go 6 degrees backward, this is 74, right? So if I place my ruler from the center to that small line on the primitive circle, right, I can actually mark on the fault plane, right, somewhere here, and that's gonna be the intersection of the linear feature on the fault plane, right? Because the Slicken line is sitting on the fault plane. We had only the trend, but when you plotting like this, you get the intersection. That's the actually now we should be able to read the plunge, right? This question is asking about the plunge of this linear feature and also the pitch, right? So for reading the plunge, you need to count from the primitive circle, right? We place it like that. Okay, from here, from the trend, we count 10, 20, 30, 30, let's say 38. All right, plunge is 38 degrees. How about the pitch? So the pitch, as we said, you need to count along the fault plane. You can count from either side, but you need to mention we are counting from which end, right? Normally I go with the small angle. So here I need to place the great circle along the north-south direction, and then now I should be able to count this on the fault plane: 10, 20, 30, 40, 50, 57, right? So the pitch is 57 degrees, and I'm counting from southeast, right? So that is the answer for this question.